All right, so today we are going to be diving into the life and work of pretty huge figure, Stephen Hawking, and we're going to be focusing on the book Hawking y los Buracos Negros.
Yeah, and the book sets up this image of him that's a little bit paradoxical.
Yeah.
It starts by saying that he's kind of like Dr. Strangelove,
Uh-huh.
with his like huge intense intellect and kind of a caricature of a brilliant mind, but at the same time, the book emphasizes that he was also a very normal human being.
So let's try to understand how that's possible.
Mm-hmm.
The book talks about his office at Cambridge.
Yeah.
And it says that, it's full of screens and equations and a mirror so he can look at his own thoughts.
Right.
But it also says that there's this poster of Marilyn Monroe.
Right.
Which is this kind of strange contrast between, this guy who's trapped in this body and he can't move, but his mind is exploring the universe.
Mm-hmm.
So what we're going to try to do today is to kind of extract the essence of Hawking's life and work, particularly his ideas about black holes and that really tricky theory of everything, right? The origin of the universe. But we're also going to tackle this kind of fundamental question that has always haunted cosmology.
Yeah.
Is it really science?
Oh, yeah.
In the strictest sense.
That's a great question. And the book doesn't shy away from the fact that, cosmology, it's built on this very intricate mathematical framework, right?
Right.
But actually being able to test a lot of the ideas about the origins of the universe or its ultimate fate, it's still really, really difficult.
Yeah.
So you kind of wonder about this whole idea of scientific proof, when you're dealing with things that are way beyond our direct observation.
Right. So Stephen Hawking, born January 8, 1942, in Oxford.
Yeah, smack dab in the middle of the bliss. I mean, what a time to be born, right?
Yeah.
And, the book points out this incredible coincidence. He was born on the exact same day as Galileo. And in the same year as Newton, it's almost as if, destiny had a plan for this guy from the very beginning.
So his parents, Frank and Isabel Hawking, both Oxford grads. And Isabel's story is really interesting.
Absolutely.
Because it tells us a lot about the intellectual atmosphere at the time. She worked as a tax inspector for a while, but she absolutely hated it.
Yeah, I can imagine.
And then she became a secretary. But, her inner life was much richer.
The book mentions that she actually had communist leanings early on.
Oh, wow.
Which later sort of evolved into socialism. And she was even involved in some of the early CND marches, the Campaign for Nuclear Disarmament.
Oh, right.
So it really gives you this picture of a family that was very engaged in political and social debates, in intellectual ideas.
Yeah.
And that must have had some influence on Stephen, for sure.
Yeah. So in 1950, the family moved to St. Albans. And their lifestyle, the book says, was dangerously eccentric. Which, I think maybe unconventional is a better way to put it. Yeah. So their house was full of books. And they chose furniture based on comfort rather than style or prestige.
Right.
And they were really into listening to the BBC's third program, which is known for its, highbrow content.
Yeah, I've heard of that.
Now, here's the thing. Stephen's role models were Bertrand Russell, the philosopher.
Oh, wow.
And Mahatma Gandhi.
Oh, wow.
That's quite the combination.
That is. That tells you a lot about the values that were instilled in him from a very young age.
Absolutely.
Not just the scientific curiosity, but this sense of kind of moral responsibility.
Yeah, yeah. And for their family holidays, they would pile into this brightly colored, very bohemian trailer and head to Dorset.
So you have this kind of clash of, intense intellectualism with a touch of free-spirited bohemianism.
Yeah, exactly. Now, school-wise, Stephen went to St. Albans School, and he wasn't the star student you might imagine. In fact, he was described as small, shy, not very physically coordinated.
Yeah, kind of the opposite of what you would expect from a genius, right?
Yeah. But here's the interesting part. Even though he didn't seem to put in a lot of effort, his grades were consistently above average. He wasn't always first, but he was always up there.
That's a classic sign of a naturally gifted mind.
Yeah. And he got super into chemistry and built his own science lab at home.
Oh, yeah.
Which, the book says, was a complete mess. Full of experiments, guides for making dangerous substances.
That's incredible. I mean, you can just imagine, the young Stephen just completely absorbed in these experiments, not even worrying about the mess. And, this passion for exploration really shines through even at that early age.
Yeah. And there's another detail that I found fascinating. Stephen spent hours, sometimes even days, creating and playing complex board games,
Really?
often against himself.
Oh, wow.
And his mother even saw this as almost a substitute for life, this intense concentration.
That's an interesting perspective, but it does show that from a very early age, he had this ability to think strategically,
Right.
to kind of engage with complex systems, which would obviously be very useful later on.
Yeah, exactly. And there's this great anecdote about his classmate, Michael, who realized during a conversation about life and philosophy that Stephen wasn't just smart, he was different.
Yeah.
And he even admitted that Stephen's intellect was a bit arrogant.
Right.
But it was in that moment that Michael saw Stephen as someone who was deeply, deeply thoughtful about the big questions.
Yeah, and those big questions about life and philosophy, they really are the kind of the starting point for both philosophy and cosmology.
Right.
It's all about trying to understand our place in the universe.
Right, right. So in 1958, when Stephen was 16, his father had a chance to go to India for research.
Yeah.
And the family was going to go with him, but Stephen stayed behind to take his exams.
Oh, right.
And he lived with his family, the Humphreys.
Mm-hmm.
And there's this funny story about how the Humphreys lost a whole cartload of their best china. And Stephen, maybe he processed things a little slower at first, but he ended up laughing the loudest, even though it was a bit delayed.
So even amidst all this intellectual intensity, he still had a sense of humor.
Yeah, yeah. So his dad actually wanted him to study biology.
Oh, really?
But Stephen was, head over heels for maths and physics.
Yeah.
So they struck a deal. He would study maths, physics, and chemistry.
Okay.
And he aced the Oxford entrance exams and got a scholarship at 17.
So Oxford, with its rich history and all these brilliant minds, it must have been like this whole new world opening up for him.
Yeah. But it wasn't all smooth sailing at first.
Right.
He felt young and a bit awkward, especially surrounded by older students, many of whom had done military service.
Yeah, I can imagine.
So he spent most of his first year in his room, not necessarily studying, but feeling kind of bored and out of place.
Trying to find his footing.
Yeah. He drank beer and read science fiction.
Yeah, that's an interesting contrast. These imaginative, sometimes crazy ideas in science fiction versus the rigor of academia.
Yeah.
Maybe that early exposure to speculative fiction, even if it's not real science, maybe it helped to foster his own bold thinking.
Yeah, that's a good point. Then, in his second year, things changed. He had this, transformation. He grew his hair out. He got a better sense of humor. He even became a coxswain on his college rowing team.
Really?
Yeah.
So the shy, uncoordinated guy suddenly becomes this leader, this strategist.
Yeah, and the book suggests that once Hawking set his mind to something, he was incredibly determined.
Wow.
But academically, he was still super efficient. He only worked about an hour a day. But his tutor, Dr. Robert Berman, called him obviously the most brilliant student I ever had.
So just natural talent.
Yeah. And he decided he wanted to do research in cosmology.
Mm-hmm.
And he applied to Cambridge to study with Fred Hoyle,
Right.
who was like the big name in the field.
Huge, yeah.
And he got accepted, but on one condition. He had to get a first-class degree from Oxford.
Yeah, makes sense.
Yeah. Now, here's a moment that shows a lot about his character. Just before his final exams, he lost his confidence.
Oh, really?
Yeah. And he didn't do very well. But then came the interview.
Oh, right.
And when they asked him what he planned to do, depending on his degree classification, he said, and I'm paraphrasing here, "Well, my plans depend on whether I get a first."
He was that confident.
Yeah, and they were so impressed by his talent that they gave him the first.
Wow.
But when he got to Cambridge, there was a bit of a letdown. Hoyle didn't want to supervise him. Yeah, he gave him a research assistant instead.
That must have been a blow to his ego.
Yeah, and you have to remember, at that time, Cambridge was like the epicenter of scientific breakthroughs.
Oh, yeah.
Crick and Watson had just discovered the structure of DNA.
Right.
And Hawking probably realized that he wasn't the star he was at Oxford anymore.
Yeah.
And he had also been noticing some physical problems. He had fallen down some stairs at Oxford. He was having trouble tying his shoelaces.
Mm-hmm.
Yeah, and then in his first term at Cambridge, he got this devastating diagnosis. ALS, also known as motor neuron disease.
Oh, wow.
Yeah. A really, really terrible disease that progressively paralyzes you.
Right.
You lose the ability to move, to speak, but your mind stays sharp.
Oh, that's awful.
Yeah. And the doctors only gave him a few years to live.
Oh, my God.
And they said he would eventually need morphine.
How did he react to that?
Well, the book says that his initial reaction was, how could this happen to me?
Yeah.
His mother, understandably, was much more emotional.
Right.
And the specialist who gave him the diagnosis was, well, pretty dismissive.
Oh, God.
Yeah. So Stephen fell into a deep depression.
Understandable.
Yeah. He stayed in his room,
Mm-hmm.
listened to Wagner, and drank vodka.
Oh, wow.
But then he met Jane Wilde.
Oh, okay.
She was 18 years old, a devout Christian, and a very optimistic person.
Interesting.
Yeah, and she didn't even know much about cosmology at the time.
Yeah.
But she gave him this reason to live. Yeah, she provided him with this incredible support. And her personality, it just kind of lifted him out of that dark place.
That's beautiful.
Yeah. And the book says that Stephen realized that even if he was going to die soon, there were still things worth doing
Yeah.
if his sentence was suspended, as he put it.
Right.
Now, thankfully, the ALS progressed in fits and starts.
Okay.
So he had periods where he got worse and then periods where he was stable.
Right.
And he lived way longer than the doctors predicted.
Thank God.
Yeah. And his relationship with Jane was really amazing.
Yeah.
He refused to be treated with pity. He wanted to be independent.
Mm-hmm.
And they both understood that they had to make their lives meaningful.
Right.
Now, when they got engaged, it was a turning point because Stephen realized that to get married, he needed a job.
Yeah.
And to get a job, he needed a PhD.
Right.
So he had this renewed sense of purpose.
Okay.
And he decided to focus on cosmology because it relied on his brain, which wasn't affected by the disease.
That's smart.
Yeah. So in 1965, at 23 years old, he started his PhD, and he also got married to Jane.
Wow.
They started their life together in Cambridge.
And during that early period, he really just threw himself into his work.
Yeah.
Minimizing distractions, focusing on these really, really complex problems.
Yeah. Now, it's important to remember that at that time, cosmology wasn't considered a proper science by a lot of people.
Right.
It was seen as kind of a pseudoscience
Oh, wow.
that attracted, people with grand ideas, but no way to prove them.
Interesting.
But then, in the early 1960s, things started to change. Relativity and quantum theory, they were being applied to the universe, both at the galactic scale and the subatomic scale.
Right.
And this led to ideas that were even crazier than science fiction.
Wow.
And that's when Hawking noticed this kind of fundamental incompatibility. Relativity, which is great for describing gravity and the large-scale structure of the universe, it didn't seem to play well with quantum physics, which describes how things work at the atomic level.
All right.
And this became really apparent when they tried to explain black holes.
Yeah, that makes sense.
So let's talk about the history of black hole theory because it's actually quite fascinating.
Yeah, it goes way back.
It does, all the way back to 1783,
Oh, wow.
when John Michell, an English clergyman, predicted the existence of dark stars.
Dark stars.
Yeah, objects with gravity so strong that even light couldn't escape.
That's amazing.
Yeah, and Michell, he was actually quite a clever guy.
Mm-hmm.
He also had ideas about double stars and how to measure the distance to stars.
Wow.
So he was ahead of his time.
Yeah.
Now, fast forward to 1916. Karl Schwarzschild, a German physicist, he's serving on the Russian front during World War I.
Wow.
And he comes up with these solutions to Einstein's equations of general relativity.
Okay.
And these solutions showed that a collapsing star could reach a point where nothing could escape its gravity. This is what we now call the Schwarzschild radius.
Right.
And it's the boundary of a black hole. Now, the book points out this really interesting coincidence.
Yeah.
At the same time, in the same horrible context of World War I, the philosopher Ludwig Wittgenstein was working on his really deep philosophical ideas.
Oh, wow.
Yeah, it's like these two minds grappling with the nature of reality in the midst of all this chaos.
Yeah, it makes you wonder how much, the context of their time influenced their thinking.
Yeah, absolutely. Now, Einstein, he actually resisted the idea of black holes at first.
Really?
Yeah, even though it came from his own theory.
Maybe it was just too radical?
Yeah, probably.
Yeah.
Then in 1922, a Russian cosmologist, Alexander Friedman, he challenged Einstein's idea of a static universe.
Good.
He said that the universe was expanding, and it had originated from this cloud of matter.
Right.
And Einstein, he disagreed with Friedman too at first.
Oh, wow.
Yeah, but then in 1928, Edwin Hubble, through his observations, he found evidence for the expanding universe.
Oh, right.
And he did this by observing the redshift of light from distant galaxies. And the crazy thing is, Hubble didn't even know about Einstein and Friedman's theories at the time.
Wow.
Yeah. And then in the 1930s, Lev Landau, a brilliant Soviet physicist, He speculated about the existence of neutron stars.
Neutron star?
Yeah, these incredibly dense remnants of stars.
Right.
And he wrote this paper really quickly and sent it to Niels Bohr to be published in Nature.
Oh, wow.
Yeah, probably because he was afraid of, Stalin's purges.
Yeah, that makes sense.
And Bohr actually intervened to make sure it got published.
Wow, that's amazing.
Yeah. Now, building on Landau's work, in 1939, Robert Oppenheimer, the guy who would later lead the Manhattan Project,
Right.
and his student, Hartland Snyder, they developed this theory of how massive stars could collapse under their own gravity and form an event horizon in a singularity.
Okay.
And the book points out that this paper was published in the same issue of a physics journal that had an article on nuclear fission.
Oh, wow.
Yeah, and this was right at the start of World War II. So, understandably, their work on stellar collapse, it didn't get much attention at the time.
Yeah, I can imagine.
Then, John Wheeler, who was involved in developing the hydrogen bomb, he came back to cosmology and he coined the term black hole
Oh, right.
to describe these collapsed objects. But he disagreed with Oppenheimer about what was going on inside a black hole.
Okay.
He thought that you needed a theory that combined relativity and quantum mechanics to really understand it.
Right.
But despite all this theoretical work, a lot of scientists, especially in the Soviet Union, they still didn't believe in black holes.
Really?
Yeah, they thought that singularities were just mathematical errors. And at Cambridge, the dominant theory was the steady state theory, championed by Fred Hoyle.
Right.
And this theory said that the universe had no beginning and no end, and that matter was being created continuously.
Okay.
And Hoyle, he was the one who coined the term Big Bang to kind of make fun of the opposing theory.
Oh.
Yeah. But the steady state theory, it had some problems. It needed these kind of ad hoc explanations to make it work.
Like what?
Well, for example, it needed continuous creation of matter to explain why the universe was expanding. But its density wasn't decreasing.
Right.
And then there's this great story about how Stephen Hawking, at a meeting of the Royal Society, he challenged Hoyle directly.
Really?
Yeah, he pointed out a flaw in Hoyle's calculations that were supposed to support the steady state theory.
Oh, wow.
Yeah, so even at that young age, he was already questioning the big names in the field.
Yeah.
Now, the alternative to a singularity was this idea that maybe stars could collapse in a really irregular way
Okay.
and somehow fly through themselves and re-expand.
That sounds pretty complicated.
Yeah, it does. But then Roger Penrose came along, and he applied topology, which is the study of shapes and connectivity, to the problem of collapsing stars.
Okay.
And he proved that even if stars collapse in a really messy way, they will still form singularities.
Wow.
Which means that black holes are pretty much inevitable.
So black holes have this event horizon, this boundary beyond which nothing can escape.
Right.
And inside that event horizon, matter keeps collapsing to a point of zero volume and infinite density, the singularity.
Yeah. And that's where our understanding of physics breaks down.
Right.
Now, Hawking, he had this incredible insight. He asked, what if we could reverse the process of black hole formation?
Okay.
And then he applied this idea to the expanding universe.
So he saw the expanding universe as like a collapsing star, but in reverse.
Exactly. And he said that if time disappears inside a black hole, then in an expanding universe, time must be created.
Wow.
Yeah, and this led him to the idea that the universe began as a singularity, the Big Bang.
Right.
And he argued that the laws of relativity, they should work in both directions. So just like gravity gets stronger as things get closer together, gravity weakens as things move apart.
Right.
And he showed mathematically that there must have been a past singularity, the Big Bang. And he even explored the possibility of a future big crunch where the universe collapses back on itself.
Oh, wow.
Yeah. So Hawking essentially provided this explanation for the origin of the universe as a kind of reversed black hole.
Right. Yeah.
And this directly challenged both the Soviet skepticism and Hoyle's steady-state theory.
And people started to take notice.
They did. But as his scientific star was rising, his physical condition was getting worse.
Right.
And he was still kind of an outsider at Cambridge. The book describes how postgraduate students would watch him struggle, first with a cane and then with crutches, which he apparently hated.
Yeah, I can imagine.
But he was still alive years after they gave him just 2 years to live.
That's incredible.
Yeah. And in 1967, his son Robert was born,
Oh, wow.
which
Okay.
showed that his body wasn't completely shutting down.
Right.
And he kept working with this incredible enthusiasm. And he even said that he felt happier than he had before his diagnosis.
Real?
Yeah, because he had this sense of purpose.
Yeah.
Now, Jane's support during this time was absolutely crucial. She was basically living with a more or less human genius, as the book puts it.
Yeah.
And he had emotional difficulties. He could be temperamental. He insisted on being treated like everyone else.
Right.
And Jane, she typed his papers. She transcribed his speech, which was getting harder and harder to understand.
Wow.
Yeah. And as he lost the ability to write, he became incredibly good at mental mathematics.
Oh, that's amazing.
Yeah, he could communicate these incredibly complex ideas without writing anything down.
That's incredible.
Yeah. Now, at DMTP, he gathered this group of really talented researchers. And in 1971, he came up with this wild idea.
What was that?
Mini black holes.
Mini black hole.
Yeah, he thought that these incredibly dense objects, maybe 1 billion tons of matter, packed into something smaller than a photon, they could have formed right after the Big Bang.
Okay.
Now, these mini black holes, they would be governed by both gravity, because of their mass, and quantum mechanics, because of their size.
Right.
So it's like a possible link between these two theories that usually don't get along.
That's really interesting.
Yeah, it was. But then there's this paradox with singularities.
Okay.
Because there are points where physics breaks down.
Right.
But they're hidden inside black holes, so we can't observe them.
Yeah.
This is called cosmic censorship.
Oh, I see.
Yeah. And it means that if physics breaks down at singularities, we can't really predict the future.
Wow.
It's like there's this huge hole in our understanding of the universe.
That's a pretty scary thought.
Yeah, it is. And there's this philosophical dilemma.
Right.
On one hand, mini black holes, they suggest that maybe there is a theory of everything, a final explanation for everything.
Okay.
But on the other hand, regular black holes, they suggest that maybe some things are just beyond our understanding.
Right.
So it's like science is pushing up against its own limits.
Yeah.
Now, let's talk about some properties of black holes.
Okay.
John Wheeler, he came up with this idea called the no-hair theorem.
No-hair theorem.
Yeah, it's a funny name.
It is.
But it means that a black hole, once it's settled down, it's only defined by 3 things. Its mass, its spin, and its electric charge.
Okay.
Everything else is lost. It's like it's been shaved off.
Wow.
Yeah, and Hawking and his team, they proved this theorem using relativity.
So no matter how complicated the stuff that falls into a black hole is,
Right.
it all gets reduced to these 3 simple properties.
Yeah. And in 1974-75, Hawking spent a year at Caltech.
Oh, wow.
Where he met Feynman and Gell-Mann, these really big names in physics.
Right.
He liked California, but he refused to go to Disneyland.
He did.
Yeah. And it's during this time that he got his Marilyn Monroe poster.
Okay.
But his disease was progressing.
Right.
He was now in a wheelchair, and his voice was becoming just a groan.
Oh, no.
But in 1979, his 3rd child, Timothy, was born.
Wow.
So life was still happening, despite everything.
Yeah.
And there's this funny story about this from a conference. Yeah, someone was introducing him, and they mentioned Timothy, and it was just this kind of awkward but sweet moment.
Oh, that's nice.
Yeah. Now, that same year, 1979, he was appointed Lucasian Professor of Mathematics at Cambridge.
Oh, wow.
A really, really prestigious position. Newton held that position.
Right.
Babbage, the computer pioneer, he held it too.
Yeah.
And Hawking was really honored.
Mm-hmm.
But when he had to sign the book, it was with great effort.
Oh, wow.
And he later said that was the last time he ever signed his name.
Wow.
But he was determined to keep living his life.
Yeah.
He went to restaurants, parties. He was known for being a good host.
Yeah.
With Jane's help.
Right.
And he was sad that he couldn't play with his kids the way he wanted to.
Oh, that's heartbreaking.
Yeah. But he also used his position to advocate for disabled people.
Okay.
He wrote to the Cambridge City Council about accessibility, and he even got an award from the Royal Association for Disability and Rehabilitation.
Good for him.
Yeah. And in his inaugural lecture as Lucasian professor, he asked, "Is the end in sight for theoretical physics?"
A provocative question.
Yeah, and he was really driven by this quest for the theory of everything.
Right.
This idea that there's one set of equations that can explain everything in the universe.
So this idea of a final explanation, it goes way back, right?
Yeah, to the ancient Greeks.
Yeah.
Thales thought everything was made of water.
Yeah.
Heraclitus thought it was fire. Democritus thought it was atoms.
Right.
And in his lecture, Hawking said that he thought a theory of everything might be found by the end of the 20th century.
Oh, really?
Yeah, and he even thought that supergravity Na8 might be it.
Okay.
But then he started to favor superstring theory.
Right.
This idea that everything is made of tiny vibrating strings.
Yeah.
But he admitted that it would take at least another 20 years to figure it out.
Wow.
Yeah. Now, there's this interesting philosophical angle to all of this.
Yeah.
Wittgenstein, he said that even if we solved all philosophical problems, it wouldn't really change anything.
Right.
And maybe it's the same with the theory of everything. Even if we find it, maybe it won't change our fundamental relationship with the universe.
Yeah.
Now, despite his illness, Hawking continued to travel and lecture, and his memory was just phenomenal.
Right.
There's this story about how, at a seminar at Caltech, he dictated this 40-term equation entirely from memory.
Oh, wow.
Yeah, and Gell-Mann had to correct him on one term, but that was it.
That's incredible.
Yeah. And then, in the early 1980s, he decided to write a popular science book on cosmology,
Okay.
mostly to earn money for his daughter's school.
Right.
Guys, see you in another podcast. Don't forget to subscribe to our channel